Hi, everybody. Welcome back to Chemistry 131, where the cat is meowing at me. I hear her, but I don't see her. Oh well, I'm sure she'll pop up, and you'll get to meet Maya if you haven't already. Oh, there she is. She's in the hallway. What are we gonna do today? We are going to talk about how to access lab content in Chem 131, as well as a little bit of a tutorial on the first experiment. So what I'm going to do is first I want to go to here. You'll notice that I have nothing captured. It's kind of boring. We're going to capture canvas, and that doesn't fit in the window. There we go. All right, let me make this a little smaller so I can make it bigger for you here. So this is our canvas page. And what you'll notice is that there should be a section down here that talks about laboratory documentation. You won't have this link to this organic structure utility. This is what I was using before I found MolView, and MolView is way better. We're going to talk a little bit more about MolView because we're going to use it in the experiment today. But here's what you need to do for the first experiment, and then for any other lab in the future, what you're going to do. First thing you're going to want to do is you're going to download the PDF. So that's this file right here. It will take you to a separate screen, and then you can access all of the instructions. Okay, so these are just instructions, and there's a whole documentation telling you about what to do, and there will be questions that you'll need to answer. Okay, now you're going to put those answers in a specific spot, and that specific spot is in the Google Sheet right here. So what you want to do for this is you want to open this file, and I'm going to open this in a new tab, which it did and it didn't. There we go. And then you'll get a screen that looks like this. And I'm going to have to cover up the chat for a second here while I make this. Oops, that's not what I want. There we go. A little small on the screen, but that's okay. So if you follow the links to that page, you will see the screen that looks like this. Okay. What this is the worksheet that you are going to fill out. The way that you're going to do that is you're going to fill out the lab report by filling in all the fields that are in light blue, like this. Okay, so you could see this. The only one you don't have to fill out is the instructions field, like this. Oh my goodness. Why are we all meowing? I don't know what's going on. There are a few tabs that you are going to need to navigate to, and those are listed down at the bottom. It's kind of hard to see, but down here I'm switching between different tabs. The reason that I have these tabs set up is because I don't want to have 30 million questions on one page, so you just keep scrolling down and down and down forever. So you're going to answer a series of questions, and then the directions on the... Oops, that's not it. Where is it? This. There we go. The questions in the lab worksheet will match up with the questions in here. So like here's question 1, using the MolView, draw the line angle structure of ethane or whatever. So you're going to do that in this box right here. We're going to talk about that a little bit more in just a second. When I am grading your report, what I do is I put scores in this column. And so you can see that when I put a score in here, it updates how many points are on this tab and how many points you have overall. I can give you any score that I want to. There you go. Now you have an A in the class because that's way more points than is possible. So because I have set up the formulas to work like that, don't write anything in column A. Never type anything in there. I know a lot of people, when they download the sheet, they start typing and they accidentally do this. That's okay. But don't write in my formulas. If you break the formulas, then I can't grade your paper. Okay. So very important. that you are not doing anything in the first column. The second columns and beyond, you can do whatever you want to, but I only grade what's in the blue areas, okay? If you leave a blue area blank, you get no points for it. If you answer a question incorrectly, typically speaking, you will get partial credit if you're close. If you're completely correct, obviously, you get full credit. But the worst thing you can do is leave an answer blank. When I grade your reports, what I tend to do is I will select a space next to it, and then I will type a comment. Like, this structure is actually a different molecule. So maybe you did the wrong molecule or something. And then what I'll do is I'll do this, and I will paint it yellow. And I paint anything yellow or a bright color so that you see my remarks when you download it. Okay, so let me undo all of that. Okay. Now, if you're working on the sheet right now, you've probably noticed that you can't type anything in here. I can, but that's because I have made the master copy here. If you type stuff into the master copy, then whoever downloads it after you will also get those remarks. So here's what you need to do in order to get your own copy of the worksheet. So first you got to go to File, and you got to click Make a Copy. And when you do that, it's going to ask you, where do you want to save this? And it'll probably go in your drive, and that's fine. You want to name it whatever you want to. So I'm going to just name this demo copy 131. But specifically for your circumstances, you should name them something so that you can keep them. Oh, excuse me, you can keep them in a folder so that you have access to them, okay? Do not click share it with the same people because then everybody else will have access to. I can't find the link you're talking about. I have downloaded the worksheet, but there's no Excel file. The Excel file should just be in Canvas. If you go to this link right here, Google Sheet for lab worksheet number 1, and when you click on that, you will get to this screen. Try that and let me know. Everybody should have access to it. I could see some people already have access to it, so it must be working. Once you download your own copy, then you will have your own copy to work with, and you can type in whatever you want to. Okay? Once you have done the experiment, the way that you submit your information is the following. You're going to go to File, and you're going to go to Download, and you're going to do Microsoft Excel.xlsx. You have to do it this way. If you choose to download the file and then upload it in some other processor and then submit it to me, it won't work. Use Google Sheets. If you use Excel 2021 or whatever version they're on, it won't work with my setup, okay? You have to use Google Sheets to do your work. If you use any other processor and I open your file and it tells me this doesn't open because you are using whatever other system, I will give you a 0, okay? If I can't open your file, you get no credit, okay? I have tested it with this setup and it works. Unfortunately, I am using an ancient copy of Excel, but downloading it straight from Google and then opening it in my Excel works fine. I don't have access to a modern version of Excel because I can't get to my computer at work. So this is the method that I am adopting because it works for me, okay? So please bear with me. So download an XLSX file, and you should get a little pop-up that says, where do you want to save this to? And you'll save it to your desktop or something. Don't open it. So I'm just going to save it to the desktop, sure. And then when you go back to Canvas, if you go into the Assignments tab, at some point there will be an assignment here that says lab number 1 submit. So I'm actually going to make that assignment really quickly for you, just so that you can see that. Okay, so let's see here. Do work on Google, then download and upload using Excel. That's correct. Okay, so we're going to call this lab. We'll call it laboratory worksheet number 1. Okay. And then please submit your .xlsx file for laboratory worksheet number 1 here. Okay, and so labs are worth 25. This is a lab. Display grade is points. You are going to submit a file. You can only submit .xlsx. You can submit it as many times as you want. Sign to everybody. This is due. This is Monday, so the soft deadline would be Wednesday. And then we'll just do that. All right, so if I publish it, that should now be a thing that you can see. Okay, so now this will be available. And so what you're going to do when you want to submit something is you click on lab worksheet number 1. Over on the right, you can't see it on my side because I'm not a student. Actually, you know what? Let me go pretend to be a student so that you can see that. How the heck do I do that? Oh, there it is, right there. Usually there's like a pink border. Yeah, there we go. That's what I'm looking for. Okay, so now if you want to submit the file, not modules, I want assignments. There you go. You click on this. And there's a big button. This is upload file. So you click on this or drag the file onto that spot, and it will say... There we go. So I'll put the file there. There you go. So I have uploaded demo copy 131. If you make a mistake, excuse me, and you need to upload it again, you can do that by just going here and clicking it again and then trashing the old file. You can also hit more options. I don't think there's anything in here that you need to do. Yeah, nothing in here is super useful. Okay, and then hit submit, and you will get a confirmation, and then I will grade the file. Leave student view. I will grade the file, and you will get comments on the file that I re-upload. Okay, that is the gist of how to submit lab assignments for this class. So if you have any questions at all on how this works, let me know so that I can answer them, obviously. The next thing I want to do, so I want to, let's see here. I want to capture this thing, PDF, yeah. Okay, the next thing I want to talk about is the experiment itself. So let's make this, let's get rid of these Adobe things. Let's make this bigger. Let's talk about lab number 1 and what you're going to have to do for this experiment. So and I'm going to need to capture another. Do I have another? I don't, actually. Window capture, we'll call it that. I do want this one. Yeah. This is too big. Okay, because I'm going to need mall view here. Let me... where is it? Oh, I'm in the wrong tab. That's why. Okay. Okay, there's mall view. Okay. All right, and so when I do this, you should see mall view. Okay, cool. We won't talk about that just yet. This doesn't do me any good over here, so let me put it over here. Oops, that's not what I want. Okay, I guess I do have to leave it over here, otherwise I break the formatting. Okay, so let's talk about the first lab. The first lab is just a modeling lab, which is going to be aimed at helping you play with three-dimensional structures so that you can understand how molecular geometry works with the stuff that we're doing. Now, some of the molecules that you'll be asked to work with, we aren't going to cover until Chapter 13. We're not going to finish Chapter 12 until the end of this week. But you should still be able to make these basic structures because they're very simple. All of the content that you're going to see in this lab, we're going to talk about tomorrow. As far as like, what are these formulas? What's a condensed structural formula? What is an expanded formula? What is a line angle structure? And so on and so forth. I also direct you on how to upload images. This is going to be really important because at parts of the lab, I'm going to ask you to either take a picture of the model you made on MolView or draw a picture and upload it to your Google Doc. Okay, so let me do an example of that really quickly. So let's go to my demo copy that I have here. And you'll notice that for question number 1, it says to import an image, use insert image over cells. So what you're going to have to do is get a picture of your content that you want to upload into this cell somehow. Here's 2 different ways to do it. The first I can't really show you because it involves a phone. What you're going to do is take your phone or some other camera and take a photograph of a drawing that you draw for the Lewis structure of your molecule, send it to your computer, download it, and then upload it using this. So if I drew a Lewis structure and then saved a snapshot, you could upload it and then get it in your document. The other way that you can do that is if you're using a Windows-based PC and you have something on the screen that you want, if you push Control-Alt print screen, it will take a picture of the window that you are working with. And then you can either paste that directly into the file, or you can crop it in something like Paint. I'm going to crop it in Paint just so that I can get rid of things like the taskbar that I don't need to see. Like, you don't need to see that I have like 4 different tabs for 4 different weather stations. Like, oh, Wes is obsessed with the weather. Like, yeah, I love meteorology. It's a stupid hobby of mine. But now that I have that picture, what I can do is I can then copy it and then either paste it in like, I don't know if this will actually work. Hold on. Oh, I need to go over to a different window to do this really quick here. Hold on. Did that? That did work. Okay. Oh, I don't know why that disappeared. I'm sorry. There we go. So I have now pasted this picture in, but when I pasted it in, it pasted it into a cell. So you could do it that way. Obviously, this is way too big, so I'm going to make it smaller. And there you go. That's what I want you to do. Harley says that if you have a Mac, the command to screenshot is Command-Shift-3. Command is the one that looks like a flower, right? Thank you. I didn't know that. Now, don't worry about it being too small, because if your picture is too small, what's going to happen when I download it is I'm going to go, this is too small. How about I make it bigger? Oh, that looks correct. Undo. And then it'll be fine. So as long as you get the picture in the box, you're good. Okay? All right. So you do need to do some technical stuff for this lab, because I have no way of getting you to draw Lewis structures. And this is kind of the so the Windows one was, so there's 2 for Windows. So if you hit print screen, you get all of your monitor. And if I say monitor, what I actually mean is monitors, because if you have multiple monitors, it just print screens everything on all of your monitors. I have 2 monitors, so I get a really weird sort of setup when I hit print screen. So if you hit, I don't know if it's Control-Alt print screen or just Alt print screen or whatever, but I just hit all of them. If you push that combination of keys, you get a print screen of whatever window you are on. So For this circumstance, that was my browser. And then what you can do is you can go into Paint or Photoshop or whatever and just crop out all the shit you don't need. Once you've done that, then you can paste it into the document, or you can save it as a file and then go Insert Image, Image over Cells, and then put the picture in, or upload it from there. Okay, whatever it takes to get that in there. You're going to do that for every instance where you see this box, and I've put the directions in there each time. Okay, so they're the same directions every time. So, for instance, let's turn this off and go back to the lab. In the first question, I'm going to ask you to draw ethane. So, like, I have a little discussion that asks you to try drawing ethanol and then play with it in the model viewer so that you get used to it. Then I'm going to have you draw ethane, and you're going to take a picture of what you did. Then I have this link that you can click on, and it takes you to a video at Khan Academy where you can look at how molecules actually rotate and how it talks about, well, single bonds rotate. And so you can see the effects of that. And I ask you some questions about that. And then I just keep asking you questions. And then at some point you see this. Question 7 starts on the tab marked Experimental Section 2. So what you want to do in that case is... That's not the right thing. There we go. So once you get to that point and you're done answering these questions, go to the next tab by hitting Experimental Tab 2 below. So you go down here to where it says Experimental Tab 2, and the rest of the questions are here, and you can keep going. And then they'll say go to Experimental Section 3, and you do that here. And once you are done with all the questions, you are all done. Okay? Problem 7 involves an alkene, so the alkenes are on tab 2, and then alkynes are on tab 3. If you don't know what alkenes and alkynes are, that's okay. Those are chapter 13. I ask you very basic questions about them, but the most important part of this lab is for... Oops, I gotta go back to here. Is for you, really, to just play around in... Why did I turn on exam soon? We don't need this. This can go away. The most important part for you is to play with the model viewer, which I don't have the right thing captured. Yeah, there we go. And just draw structures in it, because this could be a really useful tool. I'm going to just go over those functions really quickly. I just want to make sure it's capturing chat still. So on the top row here, we have trash everything. So this deletes the entire structure. We have erase, which erases a single atom. Notice that it's not erasing it from the model, because it needs to render the model before it can do that. So if I hit render now, it would then render the part of the molecule that exists. There's an undo and a redo button. There is a pan button that lets you move stuff around. There's a select in a square, so maybe I want to select these atoms and then move them. I don't know. There's a select in a lasso, so you could go like this. I only want to select those atoms and then move them. I don't know. Whatever you do, you. This button right here just has colors, so if you are, if you like seeing color to help distinguish atoms, you can push that. Otherwise, turning it on and off will just make it look normal. If you turn on and off this button, you will get line angle mode and then expanded formula mode, whichever one is easier for you to work with. Later on in the quarter, we're only going to be using this model mode anyway, so just be mindful of that. This just puts it in the middle. This button right here is the clean up structure, so if you are drawing a structure, which is what you do with these right here, so I'm going to say, like, I do this. Let's see here. And my alkene looks really stupid. What it's going to do is it's going to... First we'll do that just to show, like, okay, that looks really bad. Then I'm going to hit tidy up. And what it will do is straighten it out for me. Okay, so you do not need to make your model look neat. The system will clean it up for you. And then what you can do is once you have made something that you are proud of, I don't know, we'll just do this. I'm going to make this an O. And then, oops, I didn't mean to do that. I'll make that an OH. And then we'll put a double bond here. So, I don't know, we'll do this. This is benzoic acid. What does this molecule look like in 3D? Well, it's hard to tell from the picture here, but you'd be surprised to know that most of it is on the same plane and flat. So when we tidy it up, it'll neat it up, and then I'll hit 2D to 3D up here. What it's going to do is make a picture of it that I can now manipulate by spinning around over here. Now, the one thing that this doesn't do, and I wish that it did, was I can't make the molecule rotate around single bonds. So this right here, this bond, would allow this group to spin. Whereas these double bonds would not allow the benzene ring, this ring part here, to spin at all. This part's completely flat. It will just stay like that the whole time. What I want you to do is, with the combination of that video that I showed you or linked to you at Khan Academy and this model viewer, I need to do this to make my cat stop meowing at me. Between those two things, you should hopefully be able to get an idea of how these molecules look and are shaped, okay? And if you have any questions, you can always just ask me questions at any time. You can send me an email, you can ask me in the Discord, you can ask me during these questions and answer sessions, etc. Alright, that's more or less the gist of the lab. It's just to have you draw some simple structures. Normally in the laboratory period, we would have you building these. Like, we'd give you a model kit and you'd put them together. And then you would see, oh, I can't spin these things, or oh, I can. Okay. All right. You'll also be asked some questions about molecular geometry and Vesper geometry, so make sure that you review the 121 content for that, because that will be relevant. Just kind of as a short primer, any carbon that's bonded to only 3 other atoms and no electron pairs on it will be triangular or trigonal planar. So this carbon would be trigonal, this one would be trigonal, this one would be trigonal, etc. If I, oops, I hit a button on whatever that is. If I had something different, I lost my viewer. There we go. So, like, say this, and then I hit tidy up. All right. That looks kind of, that actually didn't tidy up very well. So what I'm going to do is I'm going to select this atom and I'm going to just, oh. That didn't quite work. Okay. Can we tidy up again? Can we make this look a little nicer? I guess not. Okay, so the program, I guess, is not as perfect at this as I thought it would be. But there we go. We'll do that. That's much better. Okay. So any carbon that has 4 atoms connected to it, so that'd be this carbon is connected to 1, 2, 3, 4, is going to be tetrahedral. This carbon is also attached to 4 things. 1, 2, 3, 4. When I convert this to 3D, what you're going to see is this is just a bunch of tetrahedrons. So you could see that. Here's my tetrahedral shape. There's my central atom. The carbons themselves make tetrahedrons, and then each carbon at the end makes tetrahedrons with the central carbon and hydrogens. Okay. And then finally, if you have something that is triple bonded together, let's put some triple bonds and some single bonds on here. And what the heck, we'll just put some double bonds on here too. So there's my molecule. The parts that are only connected to 2 things are going to be linear. Now, it looks like everything is only connected to 2 things. But remember that anything that only has 3 or fewer bonds to it will fill in the rest with hydrogens. So when I hit this, it's actually going to put in hydrogens here. Can we do practice examples for MolView during class? Sure. I can construct any molecule in MolView that you'd want me to. And you can do it too, actually. So if you aren't sure what a molecule looks like, what you can always do is you can build it in here, and you can build it really quickly, actually. Because once we learn how to use this mode, where you don't have to worry about drawing in hydrogens or whatever anymore, like now I could just do this, and then there you go. It's going to show you what that molecule looks like really quickly. And there's even a tool to let you do this for as many carbons as you want to. So later on when we get to lipids, you might be like, oh, I want to know what linoleic acid is, so let's put 20 of these here. And then we'll go C double bond O. Oops, that's not an O. And then we'll go O. And then, I don't know, I'm just going to do this. Boop, boop. I don't know what the heck. Oops, that's not. I don't know which fatty acid that is, but this is what it would look like in the model viewer. There you go. So you could see that, oh, look at this. My molecule was straight until I hit this double bond, and then it forced it to bend, and then I got another double bond, and it forced it to bend again. And so this is what's called a transunsaturated fatty acid. It causes it to bend into a different shape, which is kind of cool. Maybe that's important. Maybe it having a curled shape is different than it having a straight-on shape. So if I do this, and I make those double bonds single bonds, let's see what the shape changes to. Boop. Now it's a straight line. Ooh, I wonder if double bonds are important. And it turns out they are for fatty acids. So we're going to talk about all of that later on in biochemistry. But the model viewer is going to be super useful for you to have handy, which is why I've sort of made lab number 1 dedicated to just play with the model viewer and then build whatever molecule you want to, because at some point you will want to do that. Okay? So keep in mind that MolView is not just for this experiment. Use it as a tool. If you're looking at something in the notes and it draws like a line structure and you're like, I don't know what that looks like in 3D, I'll throw it in MolView. Go ahead and do it and see what you get, because that could be really helpful. Later on, we're also going to work with things like cyclic alkanes. So we've got things like that, and we'll put this one here. And if I do this, what you'll notice is that some of them are flat. So like this one right here is flat. And can I move them? How do I move? Oh, I have to middle mouse button. Okay. There's my cyclobutane. You'll notice, though, that, like, it's not quite square. Like, there's got some tilting going on. And then if I go over here to the hexagon one, you'll notice that, oh, wow, it's very, like, staggered. There are reasons for that, which we will talk about in the end of chapter 12. I mean, really, the reason is this is trying to be as tetrahedral as possible, and in some cases it's possible, and in other cases it's not. So, like, with this triangle over here, it can't be tetrahedral. It just does what it can. So, seeing these on paper and then seeing them in a model is very different. And if this helps you learn what things are, then, like, that's a great tool, okay? And then if you're bored, like, you can, like, just make, I don't know, you can just make faces out of it or whatever. There, whatever, right? Okay, so that's MolView. That's an overview of lab number 1. That's really all I had prepared for this. I talked about how to upload the file when you're done. I talked about how to download it. I talked about the lab itself. Yeah, I think that's it. I think that's all I have. So yeah. We'll cover this back up. At the bottom of the PDF, I have an assessment. Oops, I have to put this here. So, where it shows you how many points each question is worth. So the whole thing's worth 25. And I've sort of assigned half a point, 1 point, or 2 points to specific questions. You can see that anything requiring you to draw a model is worth 2 points, mostly for your time, because it takes effort for you to import a structure. And I realize that that is a technical thing that you may not know how to do. It's a really good skill to have, though. So make sure that you can find some way to get a picture of the molecule into your sheet. And very, very important, make sure that when you are downloading your sheet, you are doing that by going to File, Download, Microsoft Excel, XLXS, and also doing all of your work inside Google Sheets. Don't use another program. If you don't, the odds are that your graph might not appear, your images might not appear. I get reports from students every quarter that I'm like, your graph didn't show up. And they're like, well, there was a graph. And I'm like, did you use Excel or Google Sheets? And they're like, well, I used Excel. I'm like, no, you use Google Sheets. You download it to Microsoft Excel because that's how I open it. I would just make everyone make a PDF out of it, but I can't actually type into PDFs, which is unfortunate. If I had Adobe Acrobat here, I would just do that. That would be safer. You can't screw up a PDF, but okay. So that's what I have. Generally speaking, what I then do after our lab discussion, which doesn't always take an hour, it's only 12:37. What I then do is I then go here, and I say, and this is what we're going to do today. I say, we're going to have a 10-minute break. During the 10-minute break, I want you to type in anything you want in the chat here. So type any questions you might have in the chat, and we'll go over them after the break. So this could be from worksheet, from the text, just general questions, etc. If the break is over and there aren't any questions that haven't been answered, like I'll be here and just typing stuff to you, like if it's a short thing. If it's something I have to draw out, we'll wait until the break's over. But if we get to the end of the break and all the questions have been answered, then we'll just end class for the day. Lab lectures are short. That's why I put them on Monday, so it's, even if you come, it's not, if you come to lecture, it's not a long investment. And then the other Mondays are holidays. But if you do have lots of questions and you want me to answer them on the stream or show them there, because I have my tablet out, we can draw answers oh, it's minimized, so there we go. I do have my tablet. I can draw things whatever you want. That was the mouse, admittedly, but I can do that too. So let me put the timer up. Okay, and then I will hit start. And then I will go back and turn on the Paradise Killer music, which I'll just let play for 10 minutes. So let me find the song I was going to use. There it is. All right. I will see you in just a bit. Maya is here, and she has something important to say. Say hi, Maya. Maya. Hello. Hi, Maya. I don't know. I don't know if you can hear her. She's like chirping into the mic. Okay, back to the music. Oh, so close, right? Alright. That was Paradise Killer. Probably one of the games that I've played recently that I have enjoyed so much. Alright, so there were some questions about, like, how do I know how many bonds something should have? And so what I was doing, I was actually playing around in the model viewer here. And there it is. Let me window capture this. So you see what I did was I was just putting individual atoms in here, and I have no idea what this is going to do. It's probably just going to spit out one of each of them. Yeah, that's not super useful. So what I'm going to do is we're going to put one of each of these in here at a time by itself and just see what it does. Okay. So I'm going to put a single carbon atom, and what is the system trying to imply? It is trying to imply that carbon always has an octet. Well, here as drawn, I didn't bond anything to carbon. This is just a carbon that if I were to draw its Lewis structure, so if I go over here and, actually, you know what I can do? Let's capture the mol view. So let me put this here. That doesn't help anybody. Let me try and, oops, that's not what I want. I want him. Oh, I'm holding the wrong button. Ha ha ha. That's why. Okay, so we'll make this... Actually, you know what? I don't need half of this stuff here. We'll just do that. Okay, so why is the system doing this in mol view? So if I go to draw a Lewis structure of carbon, I know that carbon is in group 4, which means it has 4 valence electrons, right? And so what that means is when I go and draw its Lewis symbol, I would put 4 dots around it, right? Whenever I have unpaired electrons, those are going to be used for bonding, remember? Because bonding occurs between unpaired electrons on adjacent atoms. That's the whole theory behind covalent bonding, is I'm going to share my unpaired electron, you're going to share your unpaired electron, and we're going to make a bond. So, for instance, if I had this going on, and I had another carbon atom over here, I could share these two and make a bond out of it. Okay? If I have something that doesn't have only unpaired electrons, so nitrogen, for example, is in group 5. Oh, sorry, these are group 5A and 4A. So that would be 5 valence electrons. So when I draw my 5, I go 1, 2, 3, 4, one around each side, and then I put a second one somewhere. Then what I would do with this is I could say, well, I'll do the same thing. We'll just put all my electrons there. And then, sure, we'll do another carbon here. Whatever, right? So this can pair. But over here, this side's already got 2 electrons. Nothing's going to happen. So the number of bonds is going to be equal to the number of unpaired electrons on the symbol. Okay? In worksheet number 1, there's a review table, like at the very start of the worksheet, and it tells you all of this information. So that's just another quick review from 121. What does this mean for the model viewer? What the model viewer does is it says, okay, I expect there to be this many things coming out of carbon. If there aren't, what I'm going to do is I'm going to fill any extra spaces with hydrogen. So if you drew a structure, for example, like this, so carbon, 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 and that's all you did, then what it would do is it would go to each carbon and say, okay, carbon number 1, there should be 4 things coming out of here, but there's only 1. I'm going to go hydrogen, hydrogen, hydrogen. Carbon number 2. There should be 4 things coming out of here, but there's only 2. I don't actually want that to look like a double bond. There we go. So I'm going to go hydrogen, hydrogen. Carbon number 3. Oh, there's only 1 bond coming out of this. I'm going to fill the rest in with hydrogens. And then when you hit model, it will spit out this thing. Okay? So that's what's going on in the model viewer when you do this. We can see this in action here. So here's my carbon. I'm going to put 1 hydrogen on it. And I'm just going to leave the other one. Let me turn this mode on. It's already implying it. So when I turn this off, it's just doing that. Okay? But let's suppose that I were to actually delete one of these. So I can't do it that way. So like I drew this and I hit 2D to 3D. What should happen is nothing happens in our picture. It's just going to fill in the rest of it automatically. And when I clean it up, I bet it'll put them back. Yeah, there you go. I mean, you can't see that. I got to make it smaller. So let's do that in action for the rest of the atoms here. So I'm going to put, well, what happens if I put hydrogen down just by itself? What is that going to do? Well, it will try and bond its 1 electron to something else, which is probably hydrogen. So I expect that this will just put H2 on the screen. And I was totally wrong. Apparently it does H1. That's okay. There we go. That's what I expected it to do. But the rest of them should behave like I expected because I actually tried them. So if I just put a nitrogen in here and I hit model, how many bonds should be made to nitrogen? Well, it has 5 valence electrons. Of those, 3 are unpaired, so I should make 3 bonds. And if you go over to the model viewer, you can see that I have 3 hydrogens. Let me zoom this in a little bit. 3 hydrogens bonded to my nitrogen. And that there's this 4th mysterious blank position, and that's where the electrons go. So this is actually my trigonal pyramidal arrangement that you can see here. If I do it with oxygen, same thing. Oxygen should make 2 bonds because it has 6 valence electrons. 2 pairs of 2 for 4 total, and then 2 singles for 6 total. And that looks like this. In fact, that looks like a molecule you're probably familiar with, right? That's water. And then phosphorus is in the same group as nitrogen. So if I do both of them, they should look identical. They both have 5 valence electrons. And it turns out that they do look identical. The only difference between phosphorus and nitrogen is that phosphorus is a little bigger because it's a bigger atom. Oxygen and sulfur are also the same, so we should get the same result. And what do you know? I'm saying that before the model is done viewing or processing, but they're the same. And then I could do this, F, Cl, Br, I. And we'll put them all in there. How many bonds should they make? I'm not going to hit go yet. I want you to try and think about that. How many bonds should each of these atoms make to hydrogens? Or to anything, really. Based on the number of valence electrons they have and how many of them are free for bonding. And then I'm going to hit the model generator. We're going to look at all of them. And hopefully that was in line with your prediction. They all make a bond to 1 other thing. For some reason, fluorine was put way over here in the middle, but then this is chlorine, the green one. Bromine is usually red, and iodine is usually purple. The colors are selected because these are the colors of these things in real life, although chlorine isn't actually green. Iodine is purple, and bromine is actually red-brown, and fluorine is actually kind of a yellowish gas. But chlorine is also a yellowish gas, so I don't know why it's green, but anyway. So hopefully that clears up a little bit about drawing structures on here. There was another structure, or another question. Somebody asked about making it was C something, C4H6, was it? I'm trying to find it. Here I'm talking about it, where... There it is, C4H6O. How would you go about making that in the viewer? Now, you can't just type something in, unfortunately. What I would do is I would just put down, first I turn this mode on. So here I have 2 carbons, 3 carbons, 4 carbons. So there's C4. I need to put an O somewhere. So I'm going to do this. And then I need to put in only 6 H's. And you're going to find that that's actually very difficult to do. I'm going to do this. Oops. I'm not even putting H's in. I'm putting C's in. Sorry. 4, 5, 6. And everything needs to have an octet. Now, there is an easy fix for that, and I know the answer because I could just do this. That would be C4H6O. That's one of many ways to do it. Maybe I don't want a triple bond. Maybe I want a double bond and another double bond. So maybe I could do... So I could go like that. So I could do this instead. Oops, that's not what I want. A lot of this is just going to be you testing out things. So 1, 2, 3, 4. Oh, I did C's again. Sorry, I clicked on the wrong thing. 1, 2, 3, 4, 5, 6, C4, H6. Oh. So that could be C4H6O. And for that sort of problem, just trying random arrangements is sort of the goal. I believe that's a worksheet problem. Like I just gave you a formula and said, draw as many isomers as you can. What you'll notice about those isomers is that you're going to have the same number of double bonds every time. So you'll notice that, or what I should say is you'll have the same number of unsaturated bonds every time. So here I added 1 extra bond and 1 extra bond. So that means I added 2 lines. But in the previous structure, I had a triple bond, which would be a single bond with 2 extra bonds, or the 2 lines there. So you're going to have the same number of extra bond. We'll call it a bond order. So like I added 2 bond orders worth of bonds. I could put them both in a triple or across 2 double bonds to make this structure. And that's going to be universally true for this formula. It was C4H6O. Okay, yeah. I don't remember where that question is. I know that that's not in the lab, surely, because we haven't talked about unsaturated stuff yet. But I did put problems in the worksheet on chapter 12 that asked you to do things along that line. And they're sort of intended to be kind of review, kind of exploration, because we haven't talked about double or triple bonds yet. We will in chapter 13, for sure. All right. Does anybody have any more questions? Otherwise, I will just draw. I will draw happy faces in the molecule viewer. When you say draw a line angle, I mean the non-3D side. Yeah, that's correct. So what I have on the left side here is the mol view. Or I'm sorry, this is the line angle side right here. In fact, I think I only specifically ask you for the model side, maybe once or twice. Let me look through there really quickly. Yeah, if I don't specifically say import the model, you don't need to. Yeah, it doesn't look like I say specifically draw or import the model view in any of them. Maybe I do. I might have read it too quickly, but line angle doesn't include the letters. That's correct. Yeah. So if I import this, it's going to be kind of a mess. So import this structure, not my smiley face, of course, but there it goes. All right. Yeah, the line angle is the same as the Lewis structure, with the exception that. Well, actually, let me hit clear here. So if I draw this, oops. So let's suppose I drew propane here, and we'll just label these with C's here. Oh, I gotta turn this on. There we go. So drawing something like this would be a Lewis structure, which isn't showing up on the screen there. Let me make it bigger. So this would be a Lewis structure. It's not drawn very well. If you push tidy up, it'll draw it better. This is still a Lewis structure. Then if I go like this is the line angle structure. So line angle does not have carbons in it. It does not have hydrogens in it. So line angle, it just has lines and angles. Lewis structure has all the atoms shown. The other term that the textbook uses for the Lewis structure is expanded structure. We're going to go over all these tomorrow. And then the condensed structure would be CH3, CH2, CH3, written in like a sentence. So let me write all that on the screen so you have it in one place, so you can return to the video at some point. So if I do this, that would be the condensed structural formula. If I were to do, oops, I was trying to color code this and that didn't quite work. So if I do this, then this is the expanded structural formula. Or as we knew it in Chem 121, this is the Lewis structure. And then finally, the line angle formula would just look like that. So there you go. That should clarify everything. This is actually what we're going to talk about tomorrow. So we'll talk more about that on lecture on Tuesday. Okay. If there's any more questions, let me know. But yeah, if you spend like an hour, like maybe even this hour, just playing around with the model viewer, I think that's an hour well spent for reviewing for this lab. Honestly, if I could just make a lab that was play around in MolView, like make a structure and spin it around, like I think that would be a successful experiment. Um, the only thing MolView doesn't allow me or allow you to do is check for bond rotation, which is really unfortunate because otherwise it's really great. I understand why it doesn't do that though, because it would have to re-render every time you change the orientation of the molecule. Because it gives you like a default model that you can then spin around, but if you modify the model itself, it has to re-render it. Um, and I believe it's the web browser back end rendering it and not your computer. Over the weekend, students set up the class Discord. If you have not got into the Discord and you are interested in doing that, make sure that you join using the invite link. I see 5 people in there so far. If you would like a space to communicate with other students or me, please join us. Let me know if the invite link isn't working. I don't know if I can generate invite links, but somebody in there can. I know they expire after a while in some cases. Let me know if something's not working. Looks like there aren't any more questions because I sort of just talked for 2 minutes. So we're going to go back to here. I'm going to turn on the outro music and just talk over it for a second here. But I do want to thank everybody for coming out today to the lab lecture. Make sure that you are going over this for... Oh, wait a second. Hold on. We're not done yet. I know what I need to talk about. I have one last thing I want to talk about, and that's the due date. When is this due? Duh. When do I turn it in? So, you should now have an assignment in the Assignments tab. And you'll notice that there is a due date. Or, I'm sorry, there's an available date and a due date. The due date is 1 day before the available date. And so the due date is the soft deadline. This is what is printed in the syllabus, okay? So you have a week to do this experiment, and you can do it whenever you want. You might want to wait till after tomorrow so that you can see what structures are when we draw them in class. Or you might want to start tonight because you have time or whatever. You can do it however you want to. But you have until January 20th to finish the experiment and upload it. But if for some reason you need an extra day, I provide an extra day. It will just flag you as late. So you may turn in the experiment until the 21st, and that's the hard deadline. After January 21st, 11:59 p.m., I don't accept them anymore because that's when I download them and grade them. So please get your assignment in by the 20th if possible. The 21st is the last deadline, okay? I put 2 deadlines because for some reason putting a second deadline means everybody makes the second one even if they miss the first one. And it will flag it as late, and I don't care. I ignore any late submissions. It doesn't matter. How can you join Discord? If you go to the Announcements tab, there should be an announcement about Discord. There it is, right here. You can click on this link right here. Actually, you'll have to paste the link because it isn't clickable for some reason. If you have never used Discord before, what you do is you go to discord.com and you will make an account through them. You can also download the client and make an account. If you prefer to just use the web browser, that's fine. Like, make a username, make a password, log in, and then it will say, hey, what server should you join? And you would say, I have an invite code, and you would paste this link in there. Let me see if I can get that on the screen. I have to crop this because I don't want to put student information in the stream. Like, you'll see it, obviously, if you join the Discord, but other people might find this video, so let me see here. that's the one I want, right? Yeah. Okay. So let me do this. Okay. So there are people, here's what the Discord channel looks like. But presumably, if I click over here, this is the web page after you've logged in. If you click add a server, it will say, have an invite already? Join a server. And then you paste the link in the announcements here, and it should invite you to the server. Okay? If the link doesn't work, let me know. We'll get you a new one. But there's very little going on here right now, so like it's mostly me talking. But if you have questions for me, this is a great place to type them because you can private message me or type in something that like will make a sound and then I will hear, oh, a student messaged me. I will go check that. And so on and so forth. So Discord is super useful for communicating. And if that is something that would help you, please join us. Okay. There we go. So now I talked about the deadline. It says it's expired. Okay. Who's in charge of getting an invite link? Can you get me a new one? Let me see here. What do you mean on question 9 and 12 by molecular geometry between the bonds on 3D model? Is that the lab? Let's see here. Yeah, so what I mean by that question is, let me get the model viewer back up. That's not the window I want. There we go. Boop. So what I mean is when you draw the structure, so I don't know, I'll just put benzene down. And I say, okay, let's look at this carbon over here, which would be, sure, this one, whatever. Ah! I'm trying to spin it around and it's not really working. By looking at the model viewer, and spinning it around all the different ways, what do you see about the molecular geometry around the carbon atom? So you'll type in what molecular geometry that is. So that's going to paste a new invite link. I will go back and I will modify the announcement to just get the new invite link. Seth, that there's an option that you can make it like a permanent invite link. I don't know how invite links work, actually. Check that, and then I don't have to keep pasting new invite links. But yeah, email that to me, and I will paste a new one. Okay. I'm sure that there's a way to do it because there are. I don't know. You might have to make it a paid server. Don't do that. Don't pay for the server. I will look into that too. Okay. So we'll go back to here. If you have any other questions, please let me know by email. I'll be happy to answer them. Other than that, make sure to get the assignment in by the deadline, and you'll be all set. Have a wonderful rest of your evening, and I will see you tomorrow for the continuation of Chapter 12.